Good day, sir, and good day, everyone. Today, our Vietnamese group have 4 people. Is阮Văn Chuan, Phan Hoàng Phan Hoàng Jiu阮氏秋and Wu Chin. We're going to talk about artificial intelligence. So let's start. This is our table of contents. Today, we're going to introduce for 5 parts. The first one is introduction, the second one is types of AI, the third is image segmentation, the fourth is AI frameworks, and the last one is conclusions. So I'll go to the first one is introduction. I want to show you the definition of AI. So AI is artificial intelligence. It's the ability of computers or smart device to perform tasks that previously only humans can do, like acting humanly, thinking rationally, and acting rationally. For the development history, artificial intelligence has been studied since the 1950s and has been developed over many decades. Research on AI can be divided into different periods. So for more detailed development history, I will show you the periods of development history of AI. From 1943 to 1955, this is a period of theories on logic and mathematics. From 1956 to 1974 is a period of particle experiments. In 1970s is a period of stagnation. Is when AI suffers from uncertainty, difficult implementation, and high cost. And around 1980s is a period in which AI has developed strongly thanks for the development of technology. And you know that now AI is currently widely used in many fields and have many different applications. Here I will show you some most applications of AI, like natural language processing, problem solving, and business optimization, image and video processing, and big data process. The second one, I want to show you the types of AI. That is just some types of AIs I will just show you here. Is the first one is a reactive machine. That is the most fundamental type of AI. It don't have the ability to learn or store past experience. The second is limited memory. That is like store or recall past experience to make decisions. Third is a theory of mind. Like you know that the zero machine have capable of understanding the mental states or other forms of intelligence. About self-aware AI is the sense of self and consciousness. And artificial general intelligence is a hypothetical form of AI that can perform intellectual tasks at the same levels as a human being. And the last one is I will show you here is super intelligence. Like it can perform intellectual tasks for beyond the capacity of any human. So this is our mainly report today, and for these courses we research about image segmentation. Then so you know that image segmentation is the field of computer vision, and image segmentation is a process of dividing a digital image to many different parts, like collection of pixels, or can be called superpixels. The goal of image segmentation is to simplify or change the representations of an image into something more meaningful or easy to analyze. And image representation is often used to locate objects, boundaries like line or curve or so on. Or in other words, image segmentation is a process of assigning a label to each pixel in an image. Pixel in the sample label will have a similar characteristics and terms of color, intensities, or texture of the image. The result of image segmentation is a set of segments considered either the entire image or a set of contours extracted from the image. The pixels in the same regions have a similar properties in color, intensity, or texture. Labels differ significantly in their characteristics. Here I want to show you an example about for self-driving or safe-driving purpose. We'll have a street photo like this. Yeah. It's been classified by a person as who are the people, where are the road, where are the traffic lights, where are the columns, where are the vehicles, or yeah, everything here, people. Yeah, each object is assigned a label. Of course, the label names can be together, but each object is labeled. Here is also another example. So you can see that here in the picture above are taken by camera, and the picture below here has been partitioned into clusters, and each cluster will be labeled. Yeah, it will be labeled here. You can see that each color is assigned by a label. Yeah, each color is assigned by a label. So here is a picture for representational literature. So the quality is not good. You can see that because we need to calculate more, because its quality depends on the algorithms and amount of data. Another clearly example about image segmentation I will show you here. Like above, we have picture of the streets with road, vehicle, car, house, yeah, friends, or yeah, sky or something here. When you use image segmentation for this picture, you will get the result that is labeled and partitioned every part. Like the road here, that will detect by color pink, or sidewalk here will detect by color, yeah, blue, or the vehicle here is color red. You can see that something here in sky, it is sky because it's not detected, so it's unlabeled. In medical field, image segmentation also have a lot for saving time. Like for example, when you take X-rays, you will get a millions or 100 or 1,000 or millions picture from X-rays to find where the sickness inside the body. For example, here in the brain, to see and find the sickness area, you need to take a lot of picture, and the doctor need to see all of the picture to detect where the sickness and what sickness is that, what kind of sickness is that. So if you easier to use image segmentation for medical, you will easy to find where is the sickness here. So it's a save time for the teacher and for the patient. Yeah, and yeah, that is also good for medical. And another things, for example, we take the X-ray photo and you need to see clearly about where is the ball, and each image segmentation can show you that. Yeah, it can label and colorful everything inside the body, or like here lung, and yeah, every part inside the body. But that is very easy to see each part, right? Image segmentation also can apply for object detection, like detect human by zoning. Yeah, each people here is zoning by the rectangle, or the second here is semantic segmentation. It is separated by layers where is human and where is the object. And the third one here is intense segmentation. That is separated by layers and show out how many people. Yeah, you can see here how many people, and each person will assignment by a label. Very interesting image segmentation. This can have a lot of application. Like when you want to combine segmentation, semantic segmentation and classification and localization, you will get the result here. For example, we'll have the picture, and semantic and segmentation will show you where is the glass, where the cat, where the tree, and where the sky. And classification, localization will help you to detect the object by rolling, like the red square here. If you want to use that for multiple object, you can also use object detection and instant segmentation. This is an example. For we'll have picture with two dogs and one cat, and object detection will show you this is the dog, dog zoning by color. Different and segmentation will have you to detect it by different color, because there are different kind of animal. Here you can show that, you can see that object detection will zoning the object, and segmentation will show you by, let's separate by color to have you easy to see everything. Yeah, and that is the result of a science paper. Yeah, I have the link here, you can click to see that. I'll show you some code later about this result. Then now I want to talk about the application of image segmentation. So image segmentation is an important step in many different fields, such as medical image, object detection and recognition, cameras, surveillance system, traffic control system, or so on. So this technique is an important pre-processing step in most image processing system. A good partitioning result will help the later processing process to be more efficient, to save on computational cost, time as well as time, such as increasing the accuracy of the above applications. And here I want to show you the application of image segmentation in the real life. Like you can see that it reaches image beyond content. You can apply that for machine vision. A medical image include visualization from computed tomography and magnetic resonance image. Here is I list that I list out a lot of application of image segmentation here. Yeah. So in this field of object recognition, the image segmentation process separates the object from the background area. The subject here can be a person or something moving in the foreground area. Objects after being separated during the partitioning process can be processes in the system, such as counting the number of people entering and leaving, hand gesture recognition, or face recognition. In the field of surveillance cameras, the image segmentation process can be applied in identifying or monitoring objects entering the monitoring area. Motion warning when objects moving into the monitoring area. And the field of medical image techniques such as CT, it's been a computer tomography. MRI, it's been magnetic resonance imaging. X-rays, USG, indispensable for accurate analysis. Many different diseases, thereby significantly assisting doctors and diagnosing the disease. During the analysis, the diagnosis needs to extract the necessary contour surface or body parts from the image. A technique known as segmentation. However, the manual partitioning process is very time consuming and may not give good results. The partitions and borders are very important to physicians. Therefore, in the past few decades, many medical image segmentation algorithms have been proposed to increase accuracy in image segmentation. And there is some commonly used method of image segmentation. But now I just focus on trainable segmentation because it is give you the good result. To do this presentation and to know about image segmentation, I recommend you to read a book about advanced deep learning with TensorFlow 2 and Keras, or you can read some research paper or some link example here. And I also give you the course example. You can just I will just show you to more understanding about image segmentation. Here is the code. Because the time is running, so the first one I will not run again the libraries or something. You can just click the code and here the import library by click here to run. I will just show you the code for image segmentation. For this project, I use two libraries. The first one is mobile unit TV2, and the second one is expression Coco. For the first library, I will just run the code here. And try to get the result. Hey, it's no. I will run again because it's take time. First one, I will input the libraries. Finish, and I will import the helper method. This code to run library. I using here MobileNet TV2 and just see the result. Here with this code, when we input this image, you will have the segmentation map and segmentation overlay. You can see here segmentation map here have something not really good here, but it already can show you from the input picture where is the background, where the horse, and where the person, right? Yeah, I will use another library. Yeah, now have a lot of library. You can, yeah, just Google and search about library for image segmentation. You will see a lot of library, and just try it to see the difference and how to use that in the Google. Yeah, let's see the result. Because I load new library, so it will take more time to run the code. Hey, you can see here the result of segmentation map is better than the other library here. You can see exactly the partition already labeled by background, horse, and person by each color. Yeah, right. Here can try to see another picture. That is very interesting cause yeah, you can know a lot of about AI, about image segmentation. You can see here with the input have a kid with a bicycle. You can use segmentation map to see where the bicycle. This is color green one, and the person is color pink, and the background is color black. Yeah, the result of segmentation overload is very nice, right? Yeah, in this code, I can try to put our picture, our class picture last time, to try if it can detect or get some, yeah, good result. Let's see. Yeah, you see, this one the input picture of our last term group, our last term class. The segmentation map can partition and label where's the background, where's the person, and another things by color blue. Yeah, so is what I want to show you about segmentation. So back to our presentation, I would like to refer you some link here to understand more about image segmentation. And now I want to introduce and give you recommendation about the AI frameworks, because there is some best AI development tools and framework you can use like Keras, TensorFlow, yeah, some library like Scikit-learn. Yeah, you can use some of those here to develop AI. And the last one is conclusion. You see that the reasoning is the ability to solve problems by logical reasoning. And about knowledge, AI gives you ability to represent knowledge about the surrounding world. Planning, AI has the ability to set and achieve state goals beyond demonstrated knowledge. For communication, the ability to understand human writing and spoken language. Yeah. For perception, AI can have ability to infer about the world from visual image, sounds, on another sensory inputs. Yeah, that is a very small part about our course, but I hope that you get interested with the image segmentation. Thank you. Thank you for your listening.